Hi everyone. So strictly speaking, this slide should not be in the lecture at all. It uses some calculus notation, but don't worry, I'm not going to ask you detailed questions about this. Really what I want to do is set up an understanding for when we get to Maxwell's equations so that we can talk intelligently about what they are, what they mean, and how they represent the electric field and electromagnetic radiation and ultimately a theory for light. So basically what we have here are two different pictures, and this first picture is what we imagine the electric field to really look like. And basically what we have here, this is called the divergence. That upside down triangle with the little dot next to it represents the divergence of the electric field, and the divergence means just what it sounds like it means. Basically the electric field, we've got a source in the center, and the electric field spills out like a fountain, right? Or if the charge is negative, then the electric field gets sucked into it like a sink or a vacuum. And that divergence is basically what Coulomb's law tells us. Coulomb's law tells us that the electric field spills out from a positive charge, and basically what this equation captures is that the divergence is directly proportional to the charge, or the charge density really is what this represents, the charge density at that point. Over here is the other side of the coin, and basically this is saying that this symbols here represent something called the curl, so the electric curl. So again, we've got the upside down triangle with a little cross next to it, or the times symbol. And this captures the idea of circulation. So if you imagine these as being fluids, and this kind of notation actually is used in fluid flow. We didn't talk about it at the time, but we could have. And so if you imagine a whirlpool is kind of the classic example of a field that is curling around. And so again, the word curl means just what you would think it means. It means that the field curls around whatever that source is. There's also the word circulation is sometimes used, and that also is kind of means what it says. So the important thing here is that the electric field has no curl. It does not circulate at all. Basically, if you were to take, basically what that means is that the electric field does not introduce any kind of angular momentum into the field. And so basically the combination of these two is just a different way of representing Coulomb's law. And these two formulas, as we add on to them and go through the term, will eventually become Maxwell's equations.